Okay, so now see example related to relative velocity. If A and B are moving in a straight line in the same direction with velocities 2 meter and 5 meter per second respectively, what is the relative velocity of A with respect to B and B with respect to A? So now see here, in this case we assume a line here P and Q, and we assume A is going to this side and B is going to this side. Both are moving in the same direction. So this direction we can assume as positive. So this velocity is VA and this velocity is VB. Now come to the first one, velocity A with respect to B. You can write VAB is equal to VA minus VB. So we can write here 2 minus 5 meter per second is equal to minus 3 meter per second here. So see here the negative sign is showing that the passenger who is sitting in B will observe car A is moving in Q to P direction, but because I have assumed already P to Q is as positive. Now similarly you can take, this was the first part, second part, VBA is equal to, you will be getting VB minus VA, that will be 5 minus 2 is equal to 3 meter per second. So in this case the relative velocity is positive. It means the relative velocity is also coming in the direction from P to Q, because P to Q we have assumed as positive. So now we will see another example. Now see, on a 2-lane road, car A is traveling with a speed of 36 km per hour. Car B and C are approaching car A in opposite directions with a speed of 54 km per hour each. At a certain instant, when the distance AB is equal to AC, both being 1 km, B decides to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? You know it here. So the minimum acceleration required for B. So first you have to find out the minimum time available for B. So just let us discuss situation. So see here in this, suppose this is the car A is going to this side, car B is somewhere here and car C is somewhere here. This distance we take, this is 1 kilometer and this is also 1 kilometer. So B and A are in the same direction, C and A are in opposite directions. So first you have to calculate, convert also the speeds into meter per second. So we can write here 36 kilometer per hour is equal to 10 meter per second and 54 kilometer per hour is equal to 15 meter per second. So now first to find out the minimum time available for car B. So first we can calculate relative velocity of B with respect to A. So VB with respect to A is 15 minus 10, that is 15 minus 10 is equal to 5 meter per second, and VC with respect to A we can write 15 plus 10 is equal to 25 meter per second. So relative velocity of C with respect to A is 25 meter per second. Relative velocity of B with respect to A is 5 meter per second. So now see how much time C takes to overtake. From that we can get the minimum time available for B. So we know the distance, relative position is 1 kilometer and we know relative velocity. So we can calculate directly time T is equal to 1000 divided by 25, that will be in seconds. So that will be here 40. So T is equal to 40 seconds. So see 40 seconds time is available for car B, right. So this is the minimum time required or the minimum time available to avoid an accident. Now you can go for the equation of motions for the car B. We can write directly S is equal to ut plus half at square. Here we take the relative positions here. So now S is relative position, that is 1000, U is 5 into 40 plus 1 by 2 into a into 40 square. So, here you can calculate it here. This is 40 into 5, that is 200, this is 1000. If you bring it this side, that becomes 800, and 1600 divided by 2, 800. So, you will be getting A is equal to 1 meter per second square. So, you can solve this thing is here. So, the minimum acceleration of B is required to avoid an accident is A is equal to 1 meter per second square.